All right, sorry about that. Let's get started. I forgot to create the lecture question for 116. I had to do it real quick because Paul's got a lecture right after this. It's the most fun lecture question of the semester, so I can't forget that one. What's that? No, it's did you show up on time, and the lecture question's in the first minute. It's the best lecture question. Today. Oh, I won't do that in 312, but you have to be late because of. Oh, well, you don't get credit today. And I got to plug in my laptop. My laptop's dying. I'm definitely losing the lecture question point today. All right, let's do this. In my phone. So today it's more interactive demos, and it's JavaScript. I know only, at least for homework 1, I didn't double check for homework 2, but only 2 of you were using JavaScript. So it's more of a nice to know kind of thing. So that means Discord and questions will be, I think, more important this time, because if you don't want to see JavaScript, or more importantly, more specifically, if there's something else you do want to see that you want to spend this time on, and you're letting me know that, I can rush through JavaScript a bit faster and then get to something that you do want to see. If you have any specific questions or just anything, we can talk about that. And then after, if there's no questions, or after the JavaScript, or probably Friday, my plan is just to do this Friday, I'll talk about the project and project reports, and I'll go through like a sample project report. So that's coming Friday. I don't think we'll have time today to do that. Going through a report takes a whole lecture to do it right, and even then I don't get to the end of it usually. The report should be a lot of work. So if you're spending a lot of time on reports, that's natural. All right, so I want to go right to PyCharm. Yeah. So I want to run JavaScript in PyCharm. Can I even do that? CD example. I could do this, but it's not going to be as simple as it literally just hit me. Like, I'm not going to be able to run this in PyCharm, and I don't feel like going back to VS Code. CD documents, right? Or is it right in this directory? PyCharm projects. Come on. Web server. Web server from Python, examples, servers, node, server. Address in use, because my Python's still running, but that's proof that we can get this running. So let's put this over on the side, resize this, get rid of this, and talk about some JavaScript. So last time we did this, I kind of had this set up. Oh, and speaking of, I want to do the same thing I did with Python and get a separate file so I don't make the same mistake again. We can see some of the stuff that I want to talk about was already in the code the first time that I showed these servers. So I'm going to separate that so next semester I don't make the same mistake. Server, live, coding. I actually want to get rid of this. Get rid of this. Comment this out, I guess. We'll deal with that later. So what we want to do is remember where a message came from. That's our big goal with this. Python does things quite a bit different. Yeah. Today we're going to do JavaScript tutorials, so let's open PyCharm. Hey, I mean, don't have the best setup. I mean, if I was setting it up beforehand, I would have put it in WebStorm, but especially since JavaScript is so in low demand, we can do it in PyCharm, and I mean, it still does it. It does it fine. So anyway, our goal is to figure out what a message came from. And for that, we had this set up with the remote address and remote port. This is going to be the IP address and port for a connection. And that's what we need to uniquely, I shouldn't say what we need, but this will suffice to uniquely identify a client. Now, the difference in the setup of Python and JavaScript, where Python, like the receive method, was called one time per connection. It was just called once. Here's your TCP connection. Go do your thing on this separate thread. And then new connections would be created on separate threads with separate calls of that method. Not the case in JavaScript. The same in Scala using akka. I don't think I've ever even opened that server this semester. But I have a Scala example that works the same way. And other languages, I forget which other ones use this setup. In this case, every time we receive data over any TCP socket, this callback is going to be called. So this is our event-based architecture. If you recall from 116, depending on which semester you took it, whether I called it event-based architectures or not, or just concurrency in general. But we're waiting for the data event. This event occurs when there's data to be read from any TCP connection, from any of your clients. You can have 100 different clients. Whenever any of them send data, and there's data ready to be read, this is effectively like calling the receive method in Python. The handle method is called once per connection. I misspoke there. In JavaScript, it's like calling the receive method. Receive is going to get some bytes. This is like the receive method was called, and there are bytes to be read. And here are the bytes in this data. Here's the bytes of your data for any TCP connection. So the very first question we have when we receive some bytes over any TCP connection is, what the hell connection is this? What connection am I receiving bytes over? And for that, we can uniquely identify with the client remote address, the IP address and port. And then that's how we're going to know what we're looking at. So I'm going to get this client ID. I'm going to just form it as a string, then use that string to be able to do what I want. And then another nice little print statement. Let's get this just so we're responding with something. Build OK response, which is my code down here. Build response, which is going to do my content type and content length. Do I have any buffer.from? A little bit. And buffer.from, anyone who's using JavaScript is hopefully familiar with all the buffer stuff by now. Buffer.from is saying encode this into bytes. That's your dot encode in Python. So let's respond with that and do the same thing like we did before, except now, let me just get rid of all this. Now we want to check one important thing. Well, actually, let me just do the whole thing. If this is a request for upgrade to WS, respond with accept upgrade, I guess would be the way to call it. And then we want to add this client so I have my WebSocket clients up here, kind of hanging out in this mysterious land up here. This is going to be a package level variable. We don't have any classes in JavaScript, so we can't really add it to a class. We have what JavaScript calls classes. We could do something like that, but we don't have access to that. You know what? There's just not a good way to do it. So what we're going to do is create a package level variable in the server live coding package. I don't know if that's the right terminology, so don't hold me to that. But WebSocket underscore clients dot push client ID. So we want to add this client to that, my shoulder, to that list or some data structure to remember that this is a WebSocket connection. And then that's it. We're done. That's the WebSocket connection. Now, whenever we get a message, we're going to ask ourselves, is this connection a WS connection? If yes, handle as a WS frame or buffer. Oh, yeah, that's a separate thing. Else, handle as HTTP. So the first thing we're going to get this client ID and check, is this client ID in this list or in this array? If it is, then we're going to treat it as a WebSocket frame. And we could be buffering at this time too. So we also have to have another data structure. We actually have to have a couple. HTTP buffering, all the clients that are buffering HTTP, and then WS buffering. We got to remember what's buffering, because we could have multiple clients buffering at the same time. We could have a large WebSocket message coming in while somebody's uploading a large file. And this same function is going to be called on all of them. But we do have access to this socket to be able to identify the connection. And that's the information we need to figure out what exactly is happening with this particular data, what this data is that we're getting. So we're going to check, is this a WebSocket client? Is it buffering? Is it an HTTP client that's buffering? Depending on those, we're going to handle those bytes differently. And then for each buffer, actually these should be objects. For each buffer, you're going to take the client ID if we need to buffer HTTP buffering of client ID equals partially buffer data. So then you can access how much data, what are the bytes that have been buffered so far for this particular client, and get that information. Hey, my shoulder's bugging me. That's about all I want to say about JavaScript, to be honest. I can see if I have the example on here in IntelliJ. Server, CC312 server. That's probably it, right? You can see my buffering here. This is the same idea for Scala using the Akka library. I'm going to have my buffering data structure. I don't think I have WebSocket. I know I don't have WebSocket buffering. Should have WebSocket. Yeah, is WebSocket. I use the map instead of a list, so I can do O of 1 lookup instead of searching through the list. And then whenever I receive data, it's the same deal. We're going to get this received, the message that I received. My first goal is to figure out who sent this information, or rather, are they a WebSocket connection? Are they buffering? What's going on with this connection? So I'm going to check, is this a WebSocket connection? If it is a WebSocket connection, I'm going to send it to my WebSocket message handler. I'm going to parse this as a WebSocket frame, add it to WebSocket buffering if needed. Again, I don't have WebSocket buffering here. Else, am I buffering? Am I expecting to read more data? This is where I'm actually taking the content length and then subtracting. Each time I read bytes, I'm subtracting to figure out how much more information I have to read for this. So how much data am I expected to read? If I'm buffering, I have the buffering at the bottom, expected to read equals 0. So this is just handling the request, read all the information, do what you need to do. Else, I'm buffering, and I'm going to buffer and update my buffer stuff. I'm expected to read whatever I was expected to read minus what I've just read. I'm going to append to what I've just read to get the body that I'm buffering, content that I'm buffering. And then if I'm done buffering, I'm going to have a check right here. Then we're going to actually handle the request, which I don't actually do here. That's where I kind of stopped the example on this one. And I did the similar thing. I don't have as nice of a setup as the Python server, but like the request class is going to have all these state variables. The request object is going to do all the parsing. Same stuff you've done for several homeworks here. Multi-part form parsing, adding those dashes, reading the boundary. I already have my headers parsed, so the boundary I can just extract from the headers, append those 2 dashes, and read based on where those boundaries are. All that stuff you did for homework 2. It's the same setup, very similar setup to any JavaScript setup for this. And WebSockets I shouldn't open. All right, JavaScript went by way faster than I thought. There's not as much as I want to talk about just because it's less time. Suppose we can actually run it. Oh, yeah, of course. Of course it's not going to work because I added a variable that doesn't exist. But it did run. That's proof of concept enough. You know what? I do want to go a little farther than this since nobody's asking questions. Let's go a little bit farther. Or if there's anything specific you want to see in the Scala, I mean, just scrolling through code, I don't think it's super interesting. But if I'm wrong, let me know. So I'm just going to assume everything's a WebSocket connection. I'm back in JavaScript now. But I'm just going to assume everything's a WebSocket connection so we can console.log. Stringify WS, not buffering, clients, then send back nothing. Let's run this. And we can see our list growing. We get a different connection each time. And I've mentioned this before in class, but worth repeating, I think, is we can see the port numbers. We're getting the same IP address, of course, because all those requests came from the same machine. Same machine as the server. In fact, it's all just localhost. But the port is going to be not, actually, they're all the same. Let's experiment here. So they can be the same. I mean, that's perfectly valid. But we're going to get like a random-ish, port number, and we get these really high port numbers. You always hear internet stuff, web stuff works over, HTTP stuff works over ports 80 and 443. Well, it's not necessarily the case. It works on those ports for the servers, but the client ports, for the client side of the TCP connection, it's just going to be some random high number port number. So we can get different ports other than 80 and 443 on the client side. We're still getting that. Why don't I don't even have Chrome. Wow, I really don't. I never installed Chrome on this. Safari, since I'm forced to have this one. Localhost 8000. Come on. Localghost. Let's see if Safari gives us, maybe if we do it fast enough, we'll get different port numbers. So we did get the same port number each time, but different than the one that Opera uses. So they must have like some list of port numbers, and they use the first available one. You send the connection, get the response, connection's closed, that port's available again for the next refresh. So it's not surprising that it's the same one. I mean, it's perfectly valid. It's a little surprising, I guess. We did get a 31 in here, actually. It's a little surprising that it's the same one all the time, but not overwhelmingly so. If you have a WebSocket connection, this won't be the case because the connection's not closed. That connection is staying open, so that port's not available anymore. So we would get different numbers if they're WebSocket connections. But the port's going to be different. The same ports. They can be different, I guess is the point there. Yeah, there's nothing else I want to say about JavaScript since nobody's really doing it. But that's the idea of the data structures. This is what I wanted to focus on Monday. This is what I want to focus on today. How to set up those data structures to be able to remember that this is a WebSocket connection. Just a little bit different setup for JavaScript and Scala. Oh, we burned through 2 languages today, technically. You tell I gave a lot more detail to the Python example. Is there anything anybody wants to see? Nothing that you're stuck on the homeworks? It is time for C or Go. Oh, the languages. Yeah, I don't have those ready. I don't have examples set up right now. I should do Go. You want to watch me learn Go on the fly? Let's set this up. I don't think that'll be an interesting lecture. All right, well, let's do some reports then, I suppose. So, and we'll continue. I'll do more report stuff on Friday because we won't be able to do it all today. But let's at least start it, I guess, if there are no questions on other things. So here I have a server that's using Flask. Let me close everything else. So I have a server that's using Flask, so I'm importing Flask. I have my requirements.txt, which imports Flask. And we can use some Flask syntax. If you haven't seen something like this before, if you haven't seen a framework, Flask, we're going to add the path here. This is a GET request for /. I'm going to open my file webrtc.html and send that file. I'm also going to send any request that matches a file name in my public directory. The directory literally named public. Anything in here, if I get a request for a file name that matches a file in that directory, we're going to send that file. Doesn't do a whole lot, does it? That very simple server. So the idea with the reports is that if you're using a framework, I want to see what that framework does for you. So with Flask, like this will actually host this file at the root directory. Now for your homework, you had to do quite a bit of work to do that. You had to get the bytes of the request, parse the bytes of that. Well, you had to set up a TCP connection first. Set up a TCP connection, read the bytes of the request, parse it, figure out what the path is, the request type, the method, open that file. Well, the file stuff I don't care as much about. Open that file and then send that bytes of that file over the TCP connection, which means you have to form a response. So there's 3 big things in there I do care about that we're looking for in the reports, is How does this library manage that TCP connection? How does it parse your requests, especially when headers are involved? Like I want to see where the headers are being parsed, where the path and the HTTP method are being parsed, and how are you writing the responses? When you say, I want to send some information back to the client, I want to send my response, how is that response being made? That's what I want to see. And I want to see the level of detail here. I need to see in the code for the library where that stuff is actually happening, the stuff that actually looks like your homework code. So for this one specifically, we got to get to the point where we're seeing, not necessarily split, but looking for /r/n. I need to get to that level of detail. That's where you need to get to on your reports. So let's try to do that for at least one of these things in this project. And actually a little background. Goodness, that's bright. Coming up at some point here, the team project report checkpoint. I didn't talk about this yet. I think there's a little bit of explanation in the documentation. But the team project reports checkline, there's no grade attached to this. So just so you all know, there's no grade attached to this. But when we get to this checkpoint, the TAs are going to go into your repos and take a look at your reports, if there are any, and give you feedback on your reports. So if you are doing reports, by the way, a lot of teams just don't do reports and use only homework legal code. But if you do have reports, the TAs are going to give you feedback on your reports after this checkpoint, and that'll be done by the same TA who's going to grade your final project. We'll be consistent with those TAs. So any feedback they give you, if you incorporate their feedback, they're going to be judging you on the same criteria. You know, there might be slight differences between how the TAs grade. There shouldn't be. We do our best to eliminate that. But if there are, they're going to be the same TA grading your project. So if you satisfy their feedback on the checkpoint, you'll get full credit for the reports on the final project deadline. So this is strictly to give you feedback. Because reports are such a different thing, I want to make sure everybody has a chance to get a round of feedback instead of just deadline at the end of the semester and that's it. And then you get a bad grade and realize, oh, I didn't know what you meant by reports. We have this checkpoint so you can get some feedback. If you don't take advantage of this checkpoint and you lose points for reports on the deadline, don't expect sympathy. Like, get your reports, get at least drafts of your reports so you can get some feedback. So, or write one full report. I guess that would be my recommendation. So you can get some feedback as to whether or not that's what you should be doing, or do what a lot of teams do and just don't use reports. I've said this a lot outside of lecture. I think I said in lecture too, but I got to change the whole way that the project goes. I don't like that so many teams are just using homework code. I think you don't learn as much as you could by doing that. You're learning some things, but you're learning the same things you learn from doing the homework, where I want you to learning different things. Like I want the project serving a separate purpose, which is using libraries and learning how the libraries work. So in the future, I might just require libraries and reports, but I don't know how exactly to write that yet, how exactly to have that. But anyway, there is a loophole still this semester. You just use homework code. If you're using homework code, there are AI concerns for those of you doing this. There are some AI concerns, so you can't use homework code of anybody in your, like the actual code that you're submitting for credit. You can't use any of that code until after the deadlines. So for authentication, you only have a week to really get the project going. So if you're taking that loophole, just keep in mind that you really have a week to do the project. So there is some downside to that incentivizes using libraries and writing the reports. So keep that in mind. You can't use your homework 4 code until after homework 4 deadline. You can set up your WebSocket stuff. After homework 3 deadline, you can set up the rest of it and use that code. But you can't add authentication until after homework 4 unless you're... No, there's no way to do it without violating AI, is there? What? What's that?
3-hour presentation.
Yep, 3-hour presentation. If you choose this time slot, you got to present for 3 hours. Do it. I'll watch you for 3 hours. I'll watch your project. No, I'll have the presentation sign-up times, the sign-up stuff. But there will be, I forget what the math comes out to be based on the number of teams, but however long the presentations are to use this time, I think it's only 10 minutes. Okay, that can't be right. I think it is, right, though? 15. Yeah, 15 and then like another 15. Yeah, I think it's 10-minute time slots, so like 8-minute presentations, so we have time to switch for the next group. But we'll need all that time. We'll need all this time. Okay, so reports. Oh, and I keep getting questions about this. I kind of hide this a little bit, not on purpose, but I got to make this more visible. When you go to the project requirements in the project section on the course website, go to project requirements. And in the reports section, this should be the reports section, the template, of course, to figure out an idea of what you're supposed to do for these, some explanation of what they are, but then lists of libraries that do not require reports and an explicit list that do require reports. And I'll update this. If you have a question about a specific library that's not in either one of these lists, let me know, ask me, I'll make a decision, then I'll add it to one of these two lists. So there are certain things that you don't need any libraries for, but make sure you're aware, make sure you're looking at these lists and knowing whether or not you need to write a report or not for that library. Things that do not require reports includes anything that is allowed on any homework. You don't need reports for any of those. And the contrapositive to that is if there's something explicitly on this list for this, on this list, then you can use it on your homeworks. So anything in this list you can use on your homeworks. That's all fair game. Okay, so let's try to do a Flask report. What one do I want to try to find? Let's try parsing a request. Let's try to parse a request to figure out how to handle this get request first slash. How do we actually get that parsing the request line? And parsing headers will probably be right next to that code. So let's find that too. So parsing requests. Flask is doing that for us. Where, how, what's it doing? So we want to get into the Flask code to the point where it's actually parsing those that request line in the headers. Can we have Jesse as our TA? No. If you are not happy with what your TA did, you can always request me afterwards, but I don't have time to do project grading with any reasonable quality. Yeah, send from directory is the same as opening the file and then sending it, except it does some checks. Send from directory is going to have your security thing to make sure that that file actually is in this directory and make sure somebody didn't request .. It's handling that security stuff for us. You know what, let's just start right there. Man, I don't know why my shoulder's so hurting me today. I can't even move this. But let's start going through things. So your best friend when you're doing these reports is Control-click or Command-click on Mac to be able to go to the source of any method that you called. If you haven't been using this in your programming careers, start doing it now. It's the best thing ever, seriously. So where's a good place to do it? So in my server, I want to see, okay, I'm setting this equal to a new router, and I want to find the code for that router. I'm going to Control-click it, and it's going to take me to that code. What's 404? Control-click, it's going to take me there. What's generate response? Control-click. It's going to take me to wherever the definition is for whatever I clicked on. So, bless you. So that's going through my own code, but you can also do this. There's my Flask one. But you can also do this for code that's not yours. So send from directory, if I Control-click this, it's going to take me into the Python libraries, the libraries that I've downloaded using pip in this case, and show me the source code for that library, as long as I have the source code downloaded on my machine. So this is where PyCharm really shines. This is why I wasn't using VS Code for this, which I assume you can do the same thing in VS Code. You probably got to install 3 plugins, and I just don't want to. PyCharm, it's got it set up correctly. So here's the code for that. When you get into the code of these libraries, It's going to be a mess sometimes. It's going to be tough. This is not an easy task. This is why so many people just use homework code. But it's not an easy task. Right away, we find that this method does not actually read files. It's using workzug. If you're using Python and using a Python web framework, you're probably going to be in this workzug. I can never pronounce it. You're probably going to be in this library. The Python web frameworks, the ones that I've seen, rely on this library for their underlying functionality. So it actually just defers to this method, which is going to start actually doing the thing and actually raise not found, if not is file, send file, type response. Those are all parameters. Somewhere in here, it's actually going to open a file eventually, but it takes a while. It's modified, okay. Doing some caching. I must have missed it. Somewhere in here, it will read a file, or it's going to call a method that reads a file. But you're going to go through quite a few steps. This method that you call calls this method, calls this method, calls this method. And sometimes the chain won't even be like calls this method, calls this method, calls this method. Sometimes you'll get into some OOP magic where you're going to find an interface and you don't immediately have the implementation of that interface. Things get tricky at times. But what we want to see is that whole chain of calls. This called this, called this, called this. All that should be in your report. And then when you get to the last one, you say, this is where the actual code is. This is where the good stuff is. So let's try to do this for request parsing now. And for that, it's going to be a little tougher because it happens by magic in the background. So let's just go into Flask itself. I want to go into the Flask code and try to find what we're looking for. It's dangerous. Flask app is going to use that library. Look at all these imports. It's 68 lines of imports. We can see this library all over the place. And I want to find something where it's going to talk about requests, bad requests, headers, routing. That's internal. Let's start with headers, just so we can get into this library, because we know this is where it's going to be. Let's try routing. Add requests. I just want requests. Wrappers requests. Let's try this. We're in a request.py. That's a good sign. This one, your chain might be a little broken. As you can see, I kind of have to jump around a little bit. I'm going to jump over here. So we do have a regex, which is looking for that blank line in any /r/n. So this kind of gives us a hint of where we need to end up. We need to end up in this file somewhere. Debug, actually, that's probably not the right one. Find in files. Ooh, multi-part, form parsing, good stuff. Content type, and we can start to see things that look like what we're looking for. We can see looking for content type and content length. We're feeling good, and this is where we can start really looking for the code that we want to find. But that's the idea of what you want to do. I can do more of this on Friday or by request, whatever you all want to see. But are there any questions about this? Anything else you want to see right now? Or do you want to just watch me click through code? But that's the idea. You need to get to code that starts looking like your homework code. How these libraries actually do that. Because it has to happen at some point. We know that has to happen. These libraries are doing the same thing. They're implementing the same protocols. They have to do what you did on your homework somewhere. And I want to see that code. All right. If there are no questions, let's just call it right here. Or else you're going to be watching me just scroll through code, through library code. I'm looking at the... Did I miss one? I saw the shortcut keys. Can we have Josh as our TA? What's the penalty for a bad report? Oh, there's a real question here. What's the penalty for a bad report, but the project works? So if the reports are associated with each of the 5 required criteria for the project. So you have the 5 required features, and you'll be graded on each one of those separately, and they'll be weighted equally, and that'll be your project grade. For your reports, if you didn't write the reports for a specific part of the project, or specific one of those 5 requirements, then that requirement's grade will be penalized. If you have no reports at all, it's a 0. If you have reports but they're weak, then you might be docked down to like a 1 or a 2. But if you have full reports for that, it'll be a 3. But it'll be on a per feature basis. So like if you have all 5 features, everything's working perfect, and your base framework that handles parsing requests, there's no report for that, that could potentially be a 0 on the whole project. But it's on a per requirement basis. Flask definitely requires a report. Flask does a lot of your homework code for you. So anything where you're not writing code that you did on your homework and instead having a library do it for you, you're going to need a report for that. Can you use Flask and switch to homework code after 4? Yeah. I mean, I don't really care about your project until after the deadline. That's when we're finally going to go in and grade it. So if you made that switch, we wouldn't even necessarily know about it. All right, any other questions?
So Friday, you're going to do more thorough reports?
Yeah, I'll do more reports like this, and I like to do WebSockets as an example. I might do WebSockets in the report, because with WebSockets, I need to see that globally unique ID. Like that has to appear somewhere. So we got to find code that does that. Is Flask secure than Socket.io? That's a pretty vague question, I guess. I wouldn't say more or less secure between those 2 libraries. Does Flask have a built-in WebSocket library? No. There is Flask WebSocket.io, which most people use, which is a Socket.io wrapper, which Socket.io itself uses a different library. They're a big change that you'll end up following. But that's what I can demo on Friday. We don't really have time to go through any more today, though. Yeah, or if you just want to use raw WebSockets. But those are wrapper libraries that just connect one library with Flask. All right, sound good? All right. For office hours right now, I'll be in my office in a bit, and I'll see you there if you have questions.